Okay, welcome to this video on complex numbers. This time we're going to be looking at the division of complex numbers, so dividing two complex numbers. So we're going to look at a nice easy example first. Okay, number 1 I'm just going to call it. So 15 plus 10i divided by 5. Okay, nice and handy. So what you do is you just divide each term by 5. So we're going to have 15 divided by 5 plus 10i divided by 5, and I kind of written the I here because the I is going to remain I, and you just have to divide the two numbers by each other and leave I on its own there. Okay, so we're going to be left with 3 plus 2i. Okay, so that's the first example. That's kind of handy. So that's just dividing a complex number by a real number. So remember, real number is any number that doesn't have I. So let's scroll down a little bit. Next one, we're going to look at, well, before we look at the next example, we're going to actually define something called the conjugate. Okay, so I'm going to write it, the conjugate. Okay, so this is really important in complex numbers. So if z is equal to a plus bi, okay, so remember that's the form we normally write complex numbers in, then the conjugate of z bar, or z hat, so it has a little bar on top of it, is equal to a minus bi. Okay, and the important thing here, it's only the complex bit that you change the sign in front of. So we're going to look at some examples. If we call this is z, and this is z bar, I'm just going to draw a table down here. Okay, so we're just going to have a couple of different examples of each one. So the first one we're going to look at is just 2 plus 3i. If z is equal to 2 plus 3i, then what's z bar? So that's kind of what this table means, just to write the conjugate beside the original complex numbers, just so we see what the conjugate does to the complex number. So we're going to have 2 minus 3i. Okay, so just write up here a plus bi, a minus bi. Okay, next example we're going to look at is minus 3 plus 3i. Okay, the conjugate of this is going to be minus 3 minus 3i. So again, it's only the complex bit you change the sign. So again, now we're going to have 3 minus 3i. That's going to change to 3 plus 3i. Because there was a minus, we're putting, say, another minus there in front of it because it's going to be minus bi. So basically, you're going minus minus will change to plus. Okay, so keep that in mind, that if it's a minus, it'll change to plus. And again, the real bit doesn't change. And then we just have one last example. You can also just get a complex number that looks like this. Okay, so there doesn't have to be a real part. The real part could be 0. Yeah, so technically that's 0 plus the minus 3i. Right? 0 minus 3i is what I meant to say. So we can get rid of that. The conjugate of minus 3i is just plus 3i. So it's just kind of like that part of this complex number. It's just, yeah. Okay, so then you get the conjugate now, do you? So that's the idea of the conjugate, and you'll see why it becomes useful now when we do the next example. There we go. Example 2. We have 2 plus 11i divided by 2 plus I. Okay, so if you're dividing one complex number by another one, basically you can't divide anything by I, so you're going to have to do a little trick to get rid of the I in the bottom. Okay, so what we do is we find the conjugate of this, so the conjugate of that, in brackets here, is going to be 2 minus I. Okay, the conjugate of the number on the bottom always, yeah? Now we multiply, so I'm just doing a dot there. You can draw a dot, or you can draw an X. They both mean multiply, okay? The top and the bottom by 2 minus I. Okay? So the top and the bottom by 2 minus I. Yeah? So technically, 2 minus I over 2 minus I is just 1. So we're not actually changing this. We're not breaking any rules. We're just writing it in a different way. Okay? So I'm going to just do the top line over here. So 2 plus 11i multiplied by 2 minus I. So this is going to be equal to 4. So 2 by 2 is going to be 4. Minus 2i, 2 by minus I, plus 22i, 11i by 2, and then 11i by minus I is going to be minus 11i squared. So this is going to be equal to, what is going to be equal to on the top? I'm going to write for this like this. Is going to be, 4 plus 19i, and then minus 11i squared. So remember, I squared itself is equal to minus 1. So minus 11 multiplied by minus 1 is going to give us plus 11. So we're going to be left with, sorry, how did I make that mistake there? That's not going to be 20i. Let me just erase that. I was looking at it thinking it looked a bit wrong. So obviously 22i minus 2i is going to be plus 20i. Plus 20i, okay? And sorry, minus 11 by I squared is going to be plus 11, so we're going to be left with 15 plus 20i, because 11 plus 4 is going to be 15. Okay, so the real parts are the real parts, and the imaginary parts are the imaginary parts. Now I'm going to do the bottom bit. It's going to be 2 plus I multiplied by 2 minus I. Okay, I'm going to draw a line down our imaginary page here, and line across. So we're going to start down this side, we're going to finish over here. So sorry about this being a bit messy. I'll do a different color. So it's going to be 2 plus I multiplied by 2 minus I. Okay, so 2 by 2 is going to be 4, 2 by minus I is going to be minus 2i, I by 2 is going to be plus 2i, and plus I by minus I is going to be minus I squared. Okay, so these are going to cancel, minus 2i plus 2i is going to cancel. 4 minus I squared is going to be 4 plus 1, because I squared is equal to minus 1. So technically what we're going to have here is going to be minus 1, which is going to be plus 1, which again is equal to 5. Okay, so now if we look up to what we had here, 2 plus 11i multiplied by 2 minus I, it's going to be 15 plus 20i, and then in the bottom we're going to be left with 5. Okay, so our final answer, I'll do a nice blue here, it's going to be 15 plus 20i divided by 5. So again, this is going to be like the first example we did. It's going to be 15 divided by 5 is going to be 3, and 20 divided by 5 is going to be 4. So our final answer is 3 plus 4i. Okay, so a nice and neat answer for our division of complex numbers. So one thing I'll say, so hopefully that makes sense there. You have to multiply it by the conjugate on the top and on the bottom. Okay, it's always the number on the bottom. You use that conjugate. You don't use 2 minus 11i. It's always whatever's in the bottom, you multiply the top and the bottom by its conjugate. Okay, and one thing I'll just say, so we got a nice easy example here, a nice and easy answer. That's because we're just using it as an example question, but generally the answers you get will not look like that at all. They could be quite messy. You could end up with something like, say for example, 17 over 5 plus 33 over 5i. Okay, that could easily be what your answer for the division of complex numbers. So they can look quite messy sometimes. This time we got a nice answer. But yeah, hopefully that helps, and that's the trick you have to do every time when you're dividing complex numbers. Thank you.